Welcome to drillingcontractor.org. I'm Alex Indris, and I'm here with Alexis Garcia. He's Product Line Director for Performance Series Drill Bits at National Oil Well Varco. And today he's going to tell us about the Tectonic PDC drill bit at NOV. Alexis, thanks for joining us today.
Thank you, Alex.
So, Alexis, can you tell us about the challenges that drove development for the new PDC bit?
Well designs are increasingly more complex right now. The operators are drilling longer laterals that go from 5 to 8, even to 10,000 foot holes right now. And in measured depth, they're deeper. And our new product development group initiated 2 new research projects focused mainly on improving ROP. So by increasing drilling efficiency in different rock types and also in bend housing motor assemblies, which is a typical drive type globally. So for increasing drilling efficiency, our definition is having the maximum ROP for each fraction of energy that is input into the drilling system. Bend housing motors use energy to create holes inefficiently due to the air-centric motion, so a lot of wasted energy is created. And by redesigning the way the cutters interact with the hole and removing non-necessary material, we're able to take advantage of the previously wasted energy and improve drilling efficiency. The Tectonic drill bit line is all about improving drilling efficiency, which translates immediately into ROP gain. There are a lot of things that operators also look for, and it's hole quality and stability as well, and we're taking those points into consideration as well. Another very important aspect of the bit platform, Tectonic bit platform, is from the rock side, is cuttings tend to accumulate or interfere with the transfer of energy from the cutter to rock. And it may also lead to cutter balling, bit balling, and global bit balling as well, which is detrimental for the drilling process. Once any drill bit starts balling up, you'll start losing ROP, and you know you have to trip for bit. So we took a look at all those aspects in order to develop Tectonic drill bit line, and went from there.
So, Alexis, can you tell us about some of the main components of the new bit?
So Tectonic platform was envisioned to utilize proven durability, stability, and steerability bit attributes in combination with improved design methods and bit features, and all at maximizing drilling efficiency, as I mentioned before. So one of the things that we push a lot are the cutter technology. In our case, is the reflector cutter technology. They're highly mirrored, highly polished cutters that improve drilling efficiency by reducing friction. These reduce mechanical specific energy, and they improve ROP. And we've tested those cutters in the lab, and we went to the field and we started proving them through the Tectonic platform development. One important aspect is that we develop not only the polished surface, but the base cutter, which is the most important part of the cutter for it to make hole. And it's always aimed at specific drilling challenges. So for example, if you have a very abrasive rock, like a sandstone, or a very heavy interbedded sequence of rocks between soft and hard and so on and so forth, we develop and formulate the best chemistries of the cutter in order for it to withstand those drilling challenges and have the extra durability that operators need, so they don't have to trip for bits. So that's one important component. The other one is dynamic modeling, which is based on the eccentric motion of the bits when they drill in bend housing motors, which is a typical practice here in the US, where operators rotate most of the time in a lot of lateral sections. We design bits specifically to withstand those eccentric motions and uneven loads that the cutters see downhole. So that's another new development in Tectonic. Also advanced CFD. And of course, product line engineers, they have a toolkit available for them in order for them to see what the application requirement is, if it's going to be stability predominant, or is it going to be abrasion, or is it going to be steerability. They have a big array of toolkit features that they can pick and choose from for their specific bit design, so they can combat those application requirements.
What results have you seen so far from using the Tectonic bit?
Well, we've launched the Tectonic bit platform back in January this year, and we've had over 54 field records globally. So we've had those records in different applications worldwide, in different well profiles and in different drive types as well, in different well schematics or different designs. we've gone from really soft rock to the harder rock section. So like in the U.S., in North Dakota, for example, in the Bakken Formation, we've drilled with the 6-inch TK56 design, which is a 5-bladed 16mm cutter bit design in the back and in the lateral, about 9,500 foot worth of lateral section at 321 feet an hour. It set the ROP record, and it increased the ROP average by 31% versus offsets and came out in really good condition. So like I was mentioning on the longer laterals, we're constantly designing bits to overcome for the durability aspect and for the steerability aspect, because some operators or some directional drilling companies have to slide more time than expected sometimes. So we have to design the bit in such a way that we make it easier for them to slide, and then not losing ROP, which is the main driver for the operator. Also in Oman, with the 12.25 TK66 design that we have for harder rock or harsh rock on a vertical application on rotor steerable, the initial upper section was drilled with a 5-bladed 19mm cutter bit, and it set the ROP record at 19 meters an hour, previous record, followed by another TK66 at about 15 meters an hour in average. So we came back to the drawing board and we said, how are we going to make it better? How are we going to make it more efficient in terms of rate of penetration? So our engineers designed the first iteration of the TK66, and it was running the first section in the upper hole of the section, and it immediately broke the ROP record. It drilled at 30 meters an hour. And then on the second run, it drilled at 20 meters an hour. So the first run about 1,400 meters, the second run about 1,000 meters, and they both created a ROP record for the section. One of the things that impressed us was the dual condition of the bit. They were great, the cutters looked pristine, the body looked great, but we don't stop there. We keep pushing the limits, and we keep pushing the envelope on design and improving those bits in order for them to drill faster and further and comply with the application requirements for our operators.
Thanks for coming in to talk with us today, Alexis.
You're very welcome, Alex, and thank you very much.
And thank you, viewers, for joining us today at drillingcontractor.org.